friends, today we will discuss about our new topic, graphical representation of motion. For this topic, first we will discuss about the distance time graph. Distance time graph, we will represent the distance on the y-axis and time on the x-axis. This is our x-axis and here we will write the time, and this is our y-axis, and here along y-axis we will take the distance. Distance is taken in meter and the time is taken in seconds. Okay, this is our origin. Suppose we were observing any body. Let us first take the coordinates. It is 1 second, 2 second, 3 second, 4 second, 5 second. Here the each interval is of 1 second. Similarly, this is also divided in 5 segments. This is 5 meter, 10 meter, 15 meter, 20 meter, and this one is 25 meter. Suppose we were observing a body which is initially from the observer is at a distance of 15 meter. So our body is initially at time t is equals to 0 is at a distance of 15 meter, and after 1 second when we again observing the same body, it will have the same distance from the observation point of observation, and after again from 1 second it will not move from its position and have the same coordinates. Similarly, after 3 seconds it has the same coordinates, after 4 seconds same coordinates. When we join these coordinates, we will have a straight line. So from this graph we observe that the body is not moving with the passage of time, means the body is at rest. So when we have to draw a distance time graph for a body which is at the rest position, we will draw such kind of graph. So this is the graph for the rest position. Graph for the rest position of the body. Okay. Now second. Now we are taking our second case when the body is in motion. We are taking some coordinates for the time axis and the distance axis. At time t is equals to 0, the distance from the origin or the point of observation is 0, and after 1 second body covers a distance of 20 meter. Similarly, after 2 seconds it covers a distance of 40 meter, after 3 seconds 60 meter, and similarly for 4th second and 5th second. So let's draw the graph again. Again we will take distance on the y-axis and time on the x-axis. Let's take the intervals. This is for 1 second, 2 second, 3 second, and 4 second. This one is for 5 second. Similarly, this is our 20 meter distance. This is 40 meter. This is 60, and this one is 80, and this one is 100 meter. The distance is taken in meter and time is taken in seconds. So according to our data, when we draw this graph at time 0, distance is 0. So our body is at the origin. Next, for 1 second, when time is 1 second, distance covered by the body is 20 meter. Here this is time 1 second and the distance covered is 20. So our point will lie here. Similarly, after 2 seconds, the distance covered by the body is 40 meters. This is our 2 second, and this is the in front of 40. We will draw our second point. Similarly, after 3 seconds, this is our 3 second time, and in front of 60, we will draw our third point. After 4 seconds, the distance covered by the body is 80 seconds. Okay, we are drawing only the 5 points. When we join these points, we will have a straight line. So this is the curve for the distance time graph when the body is moving with uniform motion. Here we can observe that after 1 second the body travels a distance of 20 meter, and again after 1 second it travels the same distance. As we minus 40 from 20, we have 20 meter. Similarly, when we minus 40 from 60, again we will have the distance 20 meter. Here the distance traveled is equal in equal intervals. So we can write. According to the equation of according to the definition of uniform motion, which is what is the definition of uniform motion? When a body travels equal distance equal in equal interval of time, then the body is said to be in uniform motion. Here is the same case. Here the body in first second moves a distance of 20 meter. Again in the second time interval, it again covers a distance of 20 meter. So this is the equation. The graph of the distance and time for a body which is moving uniformly. Okay. Okay. Now we will see what will the slope of distance time graph represent. For finding the slope, we are making a right angle triangle A B C. A B C. Here the curve makes an angle of theta with the AB, and we know that slope is equals to tangent of theta, and in any right angle triangle, tangent theta is represented by perpendicular upon base, and here our perpendicular is CB and the base is AB. So CB, tangent theta is equals to CB divided by AB. So slope is equals to CB is the distance, or we can write CB is distance, and AB represents the time intercept. AB represents the time intercept, and we know that distance upon time is equals to speed. So slope of distance time graph is equals to speed. Okay, hope you guys understand this topic. Thank you.